In this video, I will show you how to write the equation of a periodic function like sine or cosine given the graph. Now, in the back of your mind, please understand that there is more than one right answer because of phase shifts. You could have more than one equation for each graph depending on how you look at it. For example, depending on where I start, I could look at this as a cosine function if I start off up high. Okay, I got a little off track there, but I could look at this as a cosine function. Or I could look at this as a sine function. If I start right here and look at it this way. Trying to be more careful this time than I was last time. This is really tough to do with this electronic pen, you guys. I deserve your sympathy. Okay, so when I do these problems right now, I'm going to look at the version that does not involve a phase shift just because it will be simpler. So I'm going to look at the graph this way as starting right here at 0. Just because it's the simplest way to do it. Now, given the amplitude, well, first of all, because it's starting from the midline and then going up from there, considering the way I've picked it, the way I've drawn one period, this is going to be a sine function if I look at it this way. So I'm saying y equals. Now I need the amplitude. This looks to be 3, alright, and of course this would be -3 down here, so the amplitude would be 3, so I have 3 sine. Okay, now I need the b value next. The b value is related with the period. One length of this, the length of one repetition of this function seems to be pi. So we've learned that the b value is equal to, sorry, I'm saying it wrong. We've learned that the period is equal to 2 pi over the b value. So if the period is pi, then that means pi is equal to 2 pi over the b value. We've learned that you can swap these, so this equation becomes b is equal to 2 pi over pi. So the pi's cancel out, so b is equal to 2. Alright, so that makes this 2x. And there's no vertical shift, and because of the way I picked it, there's no phase shift, so that would just be it. Now there's more than one right answer for this. I could have looked at this as a cosine function that was shifted over a little bit to the right, for example. Okay, look at number 32. Now again, if I look at the version that does not involve a phase shift, then this function is starting off high and it's going down low. So this, looking at it this way, this is going to be a cosine function. Just try to trace it a little bit. Okay, cosine function. So y is equal to, now the amplitude, it's up 0.5 and down 0.5. So the amplitude is 0.5. So 0.5 cosine. Now the period, 6 pi, is the length of one cycle. So that means we know that the period is 2 pi over the b value. So since the period is 6 pi, that means 6 pi is equal to 2 pi over the b value. I can swap these And that gives me that the b value is 2 pi over 6 pi. Okay, the pi's cancel out, and 2 over 6 reduces down to 1 over 3. So that's my b value, and that's going to go right here. All right, 1 over 3x. And there is no vertical translation because the midline is the x-axis. And there's no horizontal translation because I picked it so that it starts right on the y-axis. So I can just write the simplest version of this function like this. All right, again, there are other answers that would be also correct. Okay, look at number 33. Again, I want to avoid dealing with a phase shift if I can. So if I look at it as starting right here and falling like this, then hopefully you can see that this is a cosine function. And I'm having a really hard time tracing this. Okay, I'm looking at this cycle. So looking at this, I'm looking at it as a cosine function. Now I have to be careful about the amplitude because the x-axis is not the midline this time. That's weird. So this is 3 up and 1 down. So in other words, the total height of this thing is 4. All right, from high to low, that's a difference of 4 units. So if I cut that in half, that means 2 up and 2 down. All right, so the amplitude is going to be 2. So I can go ahead and say 2 cosine whatever. Now, while I'm at it, please understand that the midline is right here in that case. All right, that's the midline. 2 up, 2 down, it makes sense. All right, what else? It's time to find the b value. Now, one cycle has a length of pi over 2. That's the period. And we've learned that the period is equal to 2 pi divided by the b value. So that means pi over 2 is equal to 2 pi divided by the b value. So because I have a fraction equal to a fraction, the easiest thing to do is to cross multiply. So using this diagonal, that's going to be pi b, and multiplying this diagonal, that gives me 4 pi. I can get b by itself by dividing both sides by pi. That gives me a b value of 4. The pi's cancel out. So that makes this cosine 4x. Now, be careful because see how my midline is up here at 1? So there is a vertical translation right there. So I'm going to have to go ahead and put a plus 1 on the end of this. Okay, so this is one answer, probably the simplest answer for number 33. There are other correct answers depending on how you look at it, but this is the most straightforward. Okay, look at number 34. Okay, again, I'm going to try to pick the one that does not have a phase shift. Okay, so I'm going to look at this graph as starting here and going up from here and then going back down. And then back to the midline. So you can see I'm describing this midline being at -2, which means I'm going to have a vertical shift. Now, because I'm dealing with a function that starts at the midline and goes up, I am talking about a sine function. So this is y equals something sine function. Now, don't get distracted by this 2. if the midline were the x-axis, this would be 2. But look, this is going from the midline to the top. That's going from -2 to +2. That's actually a distance of 4. Okay, so this is going to be 4 sine something. Okay, and again, from -2 to -6, that's a distance of 4. So it's up 4 and down 4. That's an amplitude of 4. Okay, now it's time to figure out what the b value is. The period is 4 pi, and we've learned that the period is equal to 2 pi divided by the b value. So that means 4 pi, whoops, four pi is equal to 2 pi divided by the b value. And we've learned that we can swap these, can't we? So that makes this b value is equal to 2 pi over 4 pi. Alright, these pi's cancel each other out. The pi's cancel each other out, and 2 over 4 reduces down to 1/2. So that's my b value. So I'm going to have a 1/2 x happening. Now the midline is dropped down to -2, so I'm going to put a -2 on the end of this for the vertical shift down 2. And that is it. Alright, that is the simplest answer for number 34. There are other correct answers. Okay, write a sinusoidal function. That doesn't necessarily mean it has to be a sine function. It's just a periodic function like sine or cosine. Write a sinusoidal function with the given period and amplitude that passes through a given point. That's interesting. So I think they are forcing us to have a phase shift, basically. Let's see what happens. Okay, so the period is pi, and amplitude is 5. Okay, so if the period is pi, let's find the b value. So the period, I'll just write this off to the side. We know that the period is always 2 pi divided by the b value. If the period is pi, then that means pi is equal to 2 pi divided by the b value. These things can be swapped, so that means that the b value is equal to 2 pi over pi, and that means b is 2. Okay, so let's begin our sine function. And I might as well just use the sine function. So the amplitude is 5, so I know I'm going to need a 5 here. Okay, so I'm going to say 5 sine. Now I've got this b value of 2. Okay. Now, I could have x minus h plus k. I'm putting these extra variables in here to represent the possible phase shift and the possible vertical shift. Alright, so we have the right b value and we have the right amplitude. But if it's going to pass through this point, I'm going to have to figure out what h and k are. Okay, now here's the deal. This is really good old algebra. This is the x value and this is the y value. So what I need to do is plug those in for x and y and solve for h and k. Man, I hope there aren't too many of these, because this is really hard. Okay, let's see what we can do. So if the x value, okay, first of all, the y value is 5 over 2. So this is going to be 5 over 2 is equal to 5 sine. Okay, my x value is pi over 6. Okay, minus h, which is what I'm looking for, and then plus k. Okay, let's see what we've got. Alright, I think what we will do is let's take out the phase shift. Alright, that's too many variables. We don't need to move horizontally and vertically in order to hit this point. If we have our sine function, all we have to do, if we move it up or down the right amount, we can hit any point we want. I mean, it goes left and right forever. So if we shift it up or down the right amount, it should hit this point. So let's forget about the h and just find the k. Alright, that should be something that we can do. The other problem was blowing my mind. Okay, so look, for starters, see, I'm trying to solve this for k. So what if we divide both sides by 5? All right, if I divide this by 5, if I divide this by 5, okay, so now these 5s are going to cancel. Yeah, okay, how do I say this? So this is like, ultimately, this is going to be like having 5 over 10, right? So this is going to be 1/2 is what I'm saying. So I'm going to have 1/2 is equal to sine. This reduces as well. 2 goes into 6 3 times. So this will be pi over 3 plus k. Okay, now sine of pi over 3. We know what that is. That's that's radical 3 over 2. So this is 1/2 is equal to, you know what, that makes me wish that we had picked cosine just then, because sine of pi over 3 is radical 3 over 2. That's going to be ugly. But cosine of pi over 3 would be 1/2, which would be much nicer. So there's no rule that said that we had to do a sine function. So I'm going to change my mind and switch to cosine. I'm switching to cosine, baby. Nobody can stop me. Alright, I'm switching to cosine because that's going to be easier numbers. Cosine, cosine, yeah. Now, cosine of pi over 3 is 1/2. Okay, so that gives me 1/2 is equal to 1/2 plus k. Obviously, if I subtract 1/2 from both sides, I get k is equal to 0. Alright, that's great. So that means I don't have to put anything. So for the final answer, I feel like I need to switch colors for this, because I'm almost out of space. I'm going to switch colors. Okay, so here's the final answer. Y is equal to, alright, we want 5 cosine 2x, and we decided that k would be 0. So that's just y is equal to 5 cosine 2x. Boom! Okay, that's the first problem I ever did like that. So we could probably do them faster now that I have the idea. Okay, let's go again. We're going to need the b value, so let's go ahead and talk about that. Okay, so we know that the period is equal to 2 pi over b. So that means 4 pi is going to equal 2 pi over b. If I swap these, that's going to give me b is equal to 2 pi over 4 pi. The pi's cancel out, and 2 over 4 reduces down to 1/2. Okay, so far that gives me either y is equal to sine. Wait, I forgot the amplitude is 2. Let me get that in there. All right, the amplitude is 2, so 2 sine, and the b value is 1/2, so 1/2 x plus k, or y is equal to 2 cosine 1/2 x plus k. Alright, we just need to figure out what k is and decide whether we want to use sine or cosine. Alright, let's see what's up. This pi is the x value, and this 2 is the y value. So I'm going to take them and I'm going to plug them in over here. Man, so let's start with the sine function. So if I have, if the y value is 2, that would give me 2 is equal to 2 sine 1/2, and then I've got the pi. Now 1/2 pi is like pi over 2. Alright? Pi over 2 is the same thing as 1/2 pi. Okay, so that's my 1/2 x. And then I would have plus k, and that's what I'm trying to find. So what is the sine of pi over 2 real quick? Well, remember our unit circle. Okay, pi over 2 is up here. And the sine is the y value. So the sine would be 1 up here. So the sine of pi over 2 is 1. Okay, so that would make this 2 is equal to 2, times 1 plus k. If you subtract this 2 from both sides, you get 0 again. So 0 is equal to, k is equal to 0 if we go with this setup. Alright, so great. That tells us that the answer is, now that I know that k is 0, so the final answer is y is equal to 2 sine 1/2 x. And I'll just leave it like that because k is 0. Alright, now look, before I do number 37, I'm not doing 37 yet. I did the sine function, but this one would have worked out just as well with the cosine function. So if I had done the cosine function, the y value would still be 2. This is not number 37. Alright, I'm still doing this. Okay, so if the y value was 2, then I'd have 2 cosine. Now again, 1/2 x, if x is pi, 1/2 pi is the same thing as pi over 2. Alright, plus k. Now, now that it's cosine, cosine is the x value. So cosine is 0 up here. Alright, the cosine of pi over 2 is 0. So this would be 2 is equal to 2 times 0 plus k. So this is basically gone. So that means k is equal to 2 in this case. So another version of the answer then would be y is equal to 2 cosine 1/2 x, and the k value would be 2. Okay, so I'll say plus 2. So that is another correct version of the answer if we decide to go with cosine. Alright, now let's get back to number 37. Alright, my eraser is not working. Okay, here we go. Let's find the b value based on the period. We know that the period is always equal to 2 pi over b. Okay, if I cross multiply, that would give me pi b from this diagonal and is equal to 4 pi from the other diagonal. So to get b by itself, I would just divide both sides by pi. So b is equal to 4. Alright, great. B is 4. So that means that so far we have the following two possibilities. Y is equal to, alright, the amplitude is 1.5. So which is 3 over 2, by the way. So y is equal to 3 over 2 sine of 4x, alright, that's my b value that I just found, plus k, or y is equal to 3 over 2 cosine 4x. Plus k. Okay, now would be a good time to change colors. Alright, this is my x and this is my y. So this first equation becomes 3 over 2 is equal to 3 over 2 sine 4x. So that's sine 4 pi over 2. Alright, because that's x is pi over 2, so 4x is 4 pi over 2. Okay, and this will be plus k. If I divide both sides by 3 over 2, that's going to make 1. So this is going to make 1 is equal to sine. Alright, I'm dividing by 3 over 2. Now, of course, 4 over 2 reduces to 2 pi. Okay, so that'll be 2 pi plus k. What is the sine of 2 pi? Now 2 pi is right here. The sine is the y value. Alright, and this is the point 1, 0. So the sine is 0. So this makes 1 is equal to 0 plus k. In other words, k is 1. Alright, if we use the sine function, k is 1. Alright, so I can just go back. Actually, I'm just going to erase. And I'm going to go back and decide, alright, fine, k is 1. Okay, so that makes this one of the answers. Alright, If it's the sine function, then k is 1. Let me change colors and see if I can find the other one. Let's go green. It's always good to go green, right? Save the world by going green. So I'm switching to the cosine function now. Again, x and y. Starting off with y. So 3 over 2 cosine. Wait, it should have been, I messed up. Alright, it should have been 3 over 2 equals. And then 3 over 2 cosine. Alright, and x is still pi over 2, so this is still 4 pi over 2 plus k. So just like happened for the sine function, I have 1. I'm dividing both sides by 3 over 2. I get 1 is equal to cosine, and again this simplifies to 2 pi plus k. But this time it's cosine. So at 2 pi, cosine is 1. So this is 1 is equal to 1 plus k. So subtracting 1 from both sides, that's 0. So for cosine, k would have to be 0. So if k is 0, that means erase it. Alright, so if k is 0 for the cosine function, we want k to be 0. So it's gone, baby. So I'm just going to put a box around this now. So these are the two answers. Alright, that was pretty tough. Okay, last one. Alright, this last problem really lives up to its name. Challenge. This is going to be a challenging problem. Alright, without graphing, we are supposed to find the exact coordinates of the first maximum point to the right of the y-axis for this function. Okay, so there's a few things that would be helpful, and it would be helpful to know what's the period of this function. And to figure out the period and the phase shift, let's go ahead and factor out this 2/3 so we can see the phase shift. So if I bring 2/3 outside of this parenthesis, alright, so I'm going to have x minus something right here. To know what goes here, I need to take pi over 9 and divide by 2/3. So the question is, what is pi over 9 divided by 2/3? I need to divide this by this. Well, when you divide by a fraction, you multiply by the reciprocal. So I'm multiplying by 3 over 2. Okay, so this is 3 pi over 18. And 3 goes into 18 6 times. So this is, what did I just say? 3 goes into 18 6 times, so it's pi over 6. So this should be x minus pi over 6. Okay, so I have y is equal to 4 sine of all of this. Okay, that gives me the phase shift. Okay, so I know, I'm going to need to know the period to be able to do this problem, and the phase shift. Alright, so far I know that the phase shift is pi over 6 to the right. Okay, now I need to know the period. Well, we know that the period is always going to be 2 pi divided by the b value. So that means that the period is going to be 2 pi divided by 2/3, because that's the b value. Alright, and when you are dividing by a fraction, you multiply by the reciprocal. So this is the same thing as 2 pi times 3/2. Now this is like 2 pi over 1, this is 3/2. These 2's are going to cancel, so that just leaves me with 3 pi. So the period is going to be 3 pi. Okay. Now, we are not supposed to graph this in order to find the answer. However, there is something that you need to sort of picture in the back of your mind. First of all, this is the sine function. Okay, so if there was no phase shift, you should be thinking, all right, yeah, the sine function is has this basic shape to it. All right, also, think about the period. Whatever the period is, all right, I'll just call this P for right now, then it's going to hit this middle point at P divided by 2, and it's going to hit this high point, and this is the critical spot that we're looking for, all right, the maximum value. It's going to hit it at P divided by 4. It's like 1/4 of the period. That's when it happens. Okay, so keep that in mind. We are looking for the exact coordinates of the first maximum point to the right of the y-axis. Now, if there was no phase shift, that would occur at the period divided by 4. All right, so I feel like I should write this out in sentences. So if there was no phase shift, all right, the first maximum value would occur at x equals, all right, and it's the period divided by 4. We just found that the period is 3 pi, so that makes 3 pi divided by 4. All right, if there was no phase shift, the maximum value would occur at 3 pi over 4. Okay, however, there is a phase shift. All right, there is a phase shift of pi over 6 to the right. So given phase shift, all right, pi over 6 to the right, the maximum value should occur at the original x value plus pi over 6. All right, because we're shifting pi over 6 to the right. So what is this? Well, let's go ahead and make like denominators. So this would be, let's shoot for denominators of 12. So if I do this by 3, and if I do this by 2, okay, then that will give me 9 pi over 12 plus 2 pi over 12, which equals 11 pi over 12. Okay, so the maximum value will occur here. All right, so maximum value, value occurs at x equals 11 pi over 12. Okay, so I found the x value, but I'm looking for the y value, the actual maximum value. All right, the exact coordinates of the first maximum point. Well, so now that I read the question again, I say I'm looking for the coordinates. So I want the x value and the y value. So basically I found the x value so far. Now I need the y value. Okay, so great. The equation itself is an equation for the y value. I wonder, should I just leave it like this? So 4 sine 2/3 x minus pi over 6. All right, is that it? Yeah. Okay, so this is the equation for the y value. So I'm going to take my x value and plug it in there. Okay, I'm just curious. Yeah, I'll just stick with this. All right, so if I take the x value and plug it in right there, then I'm going to have y is equal to 4 sine 2/3. All right, and I've got 11 pi over 12 minus pi over 6. All right, all I got to do is simplify this down. Yeah, piece of cake. So let's do this off to the side. So I've got 11 pi over 12 minus pi over 6. If I just double this, all right, now I've got 11 pi over 12 minus 2 pi over 12. Oh, okay, that takes me back down to 9 pi over 12. Okay, which simplifies down to 3 pi over 4. Okay, so this is 3 pi over 4. So now I've got y is equal to 4 sine 2/3 3 pi over 4. Okay, look, guys, I'm doing this in my head, but I don't want to lose anybody. Like, these threes cancel each other out. You guys see that, right? I don't want to lose you guys. If I multiply these together, can you see that I would have 6 pi over 12? Okay, so this is going to reduce down to pi over 2. Okay, so all this in here simplifies down to pi over 2. So now I've got y is equal to 4 sine pi over 2. Okay, what is the sine of pi over 2? Well, remember, pi over 2 on the unit circle is right here. This is the point 0, 1. Sine is the y coordinate, all right, 1. So that makes this 1. All right, which means this is just 4 times 1. So the y value is 4. Okay, so we had the x value of 11 pi over 12. And now we have a y value of 4. Alright, so those would be the coordinates of the maximum value, the first maximum value to the right of the y-axis. Phew! That was rough.